This is formaldehyde. Well, not really. This is just the model. This is what formaldehyde actually looks like, but for now, we'll just use this, or more specifically, the Lewis diagram. Lewis diagrams help us visualize and understand the bonds within an atom, as well as the lone pairs of electrons that can exist within a molecule. Now let's talk about electronegativity. Electronegativity is the measure of how strongly an atom pulls electrons towards itself when forming a bond. So, for example, hydrogen has an electronegativity of 2.2. Carbon has an electronegativity of 2.55, which is less than the electronegativity shown on our periodic tables at school because there it is rounded to the nearest tenth, but really it's 2.55. Same with oxygen, which is 3.44 instead of the 3.4 that we have on our school periodic tables. Now let's talk about polarity. How do we find polarity? First, we need to calculate the change in electronegativity within each individual bond. You can calculate this by subtracting the electronegativity of one atom from another that it is bonded to. Here we have hydrogen and carbon bonded together, so to calculate the change in electronegativity, you need to subtract 2.2 from 2.55, giving us 0.35, which is less than 0.5 but more than 0, making it slightly polar. We can now do the same thing with carbon and oxygen, subtracting the electronegativity of carbon, 2.55, from the electronegativity of oxygen, 3.44, giving us the change in electronegativity of 0.89. This is less than 1.7 and more than 0.5, making it polar covalent. Now that we've found the polarity within each individual bond, we can figure out if this molecule is polar or nonpolar. Formaldehyde is polar because it has at least one polar covalent bond, the one between carbon and oxygen, as well as an overall asymmetrical arrangement of these bonds, which prevents the polar bonds from canceling each other out. It is also easy to tell by looking at the Lewis diagram that the molecule is polar because all of the polarity arrows are going in the same direction. So, now that we have the polarity, what does this tell us about the melting point, boiling point, and solubility of the molecule? Due to its polarity, formaldehyde has average melting and boiling points, those being negative 92 degrees Celsius and negative 19.1 degrees Celsius respectively, making it a gas at room temperature. Its melting and boiling points are higher than the ones of methane, a nonpolar molecule, but lower than sodium chloride, an ionic molecule. This is because the dipole-dipole and hydrogen bonds take a lot of energy to break apart, while lower overall polarity of the molecule makes it easier to break apart. As for solubility, the molecule being polar also means that it will easily dissolve in water due to its ability to form dipole-dipole bonds with H2O, which is also polar. Fun facts and uses. At room temperature, formaldehyde is a colorless, flammable gas that has a distinct pungent smell. Formaldehyde is naturally produced in small amounts in our bodies, with an average of 1.5 ounces a day just through metabolism. It is used in the production of fertilizer, paper, and plywood. It is also one of the best preservatives used to preserve human and animal remains, as well as many products used around the house, such as antiseptics, medicines, and cosmetics.